So I'm going to go over everything so that way nobody will have any questions after the last day of exams and you go, oh, I didn't know. All right, Unit 1. Unit 1 test. Chapters 1, 2, 3. Of course, y'all have your outline for this, but y'all not going to look at it. So, because that way you can say you didn't know. Unit 2. What chapters was it? I know Unit 3. Unit 3 was chapter 6 or 7. Let's see. Well, I done forgot. 7, 6, 1, 6, 2, 6, 3, or 7, 1, and 7, 2. And this was 4, 1, and 4, 2.
It was 3, 5, 4, 1, 4, 2, 5, 1, and 5, 6.
4, 1.
3, 5, 3.5.
Oh, you going out of, hold on, wait a minute. It wasn't 3, 5, because we didn't do 3, 5. Oh. 4.2. Now you said 5.1, 5.2, 5.3, and 5.5. I think that's what you meant.
Yes, sir.
Okay. And the last test, which will be due the same as the final exam. This is Unit 3, sorry. Unit 4 will be 9-1 and 9-2. And I can tell you right now, it's going to be probably 10 questions, if not that many. And it's going to be 2 or 3 formulas that, and an index card that I'm going to show you to fill out, which half of you won't do. And final exam will cover all of this material. And I've already covered that. Go through and go to your grade book and hit review, and you should be able to review any of your tests after you've taken them. Final exam, if you want to know when it's due the same as the last test. They're due on the same day. If you want to know the date, look it up on my lab's math. Okay, if it hadn't shown up yet, it will show up. Okay, so 9.1 and 9.2.
Mr. McClure.
Yes?
Could you possibly extend the test deadline for me? Because I'm going to be out of town tomorrow to next Tuesday. And I'm not going to be having...
It should be the 3rd.
Pardon? I'm going to be coming home on the 4th.
I can't go past the 3rd. They won't let us because of grade turn-in. I thought I was giving everybody a chance to do it. When do you leave?
Tomorrow.
And you don't have computer access at all?
I have a computer, but the internet is very poor and it goes on and off. And I'm going to be extremely busy because I'm going to a friend's graduation and her mom is making all the food for 200 people. And so we're going to be like cooking all day long.
Okay, well,
you better take some breaks.
I'm going to have to, let me look at grade turn-in, and let me see when I'm supposed to do grade turn-in, and I'll get back with you on that.
Okay.
All right. All right. So, first of all, I'm going to go ahead and do the index card that you're going to have to use for this unit. So I'm going to go ahead and draw it. So therefore, y'all can't say y'all don't have it, which none of y'all will do this, but well, 1 or 2 you may. All right. And I'm going to draw be about 5 columns. And this is what you should do on your index card. In other words, if you have a big index card, it's only like 5 columns. And the top Okay. And the first thing will be called confidence level. And I'm going to start at 90, and I'm going to go to 91. I'm at 99. 90, 91, 92, 93, 94, 95, 96, 97, 98, 99. Now, the computer, the homework may ask for 75% confidence level. They may ask for 100% confidence level. Why did I make this index card from 90 to 99? Because you don't want to walk into a meeting and have a confidence level of 75%. You also don't want to walk into a meeting and have a confidence level of 100%, because that would mean that your work is what?
Perfect.
Perfect. And you don't want to walk into a meeting saying that your work is perfect. All right. So that's why I make a note to say 90 to 99. The next column is called alpha. Looks kind of like a fish, backwards fish. Okay. The reason I say backwards is which way do we read? We read from left to right. That fish is going right to left. So that's why I call it backwards. So this is a percent. These are percents. So I'm just going to, since these are percents, I'm going to say 0.9, 0.91, 0.92, 0.93, 0.94, 0.95, 0.96, 0.97, 0.98, 0.99. And you might want to put those in parentheses because you don't want to think, or put an equal sign, something to show you that you're rewriting the percent as a decimal. Because you and I both know that you can't do anything with percent as far as a calculation. You have to change it to a decimal. Okay, alpha is the complement. Alpha is the complement. So the complement of 0.9 is 0.1. The complement of 0.91 is what? 0.09. The complement of 0.92 is 0.08. Complement of 0.93 is 0.07. 0.06, 0.05, 0.04, 0.03, 0.02, and 0.01. The next column is called alpha divided by 2. So somebody tell me what's a dime divided by 2? Nickel?
5.
5 cents, a nickel. 9 cents divided by 2 is 0.045. How many decimal points am I writing?
4.
4. So that means this is an area. 0.0400, 0.0350, 0.0300, 0.02500, 0.0200, 0.01500, 0.0100, and 0.0050. And those are all area. So I'm going to put Z right here, and I'm going to put
You said
inverse norm.
it's supposed to be 4 spaces?
4 decimal places.
Well, how come when you get to 0.05 is 5 decimal places?
Because I did an extra one.
Oh. Up further too, number 0.05.
Okay, thank you. All right, so now I need each of you to do your inverse norm. And somebody do inverse norm for 0, 5, 0, 0 and left. So somebody give me the z-score, and it'll be just be positive. We're not worried about negatives, just be the positive. So what is the z-score for 0.0500?
I don't know.
Did you say you wanted it to the left or center or
Yeah,
right?
left.
All right, to the left, it's negative 1.6449.
To the 2 decimal places, please.
Oh,
1
okay.
point what?
Negative 1.64.
Okay, and we're using absolute values because that's all we need. All right, somebody do the same one for 0.450.
What does it say on top of the word left? What are you doing?
Inverse norm.
Oh.
0.450. What do you get?
1.70.
All right, somebody do 0.0400.
1.75.
And somebody do 0.0350. You know, other people can do it besides Mr. Michelle.
But he does it so well.
How are you getting the z-score?
Oh my gosh.
Are you doing it on the calculator?
Second bars, inverse norm. Went through this. Second bars, inverse norm.
Okay.
0.350. I'm sorry.
1.81.
1.81. 0.300.
1.88.
0.250.
1.96.
0.200. No coughing in class.
2.05.
0.0150. Say again.
Is it negative 0.0188?
No, it should be like you see the progression. It should be more than 2.05, and you forget about the negative.
So when it has the button and asks you left, center, or right, what am I supposed to do?
Left.
Left. Okay.
I got 2.17.
0.0100.
2.33.
And 0.0050.
2.56.
Okay, now the reason I do this index card.
Hubert, excuse me, I read it wrong. It was 2.58. Sorry about that.
The reason I do this index card is so you won't have to go through the calculator and do all this, because they're going to ask usually for 90, 95, or 98%. Usually they ask for those three. The question will say, you're looking for a 91% confidence level. Okay, so I'm just going to go ahead and tell you, the reason I give you this first is because that'll save you time on the test going through the calculator. And this is the number that they're wanting. The z-score, we'll put that in green. This right here is the number they're wanting. You have to use it in the calculation. That's the number they're wanting. The number they give you is right here. This is the number they give you. They'll say a 90% confidence level. Confidence level is what's going to be in the question. So 96, Z would be 2.05. 93, Z would be 1.81. Now, I would highly recommend that you put this on an index card that has what on it?
Lines.
Lines, because that way you won't miss. You know, some of y'all can break a amble with a banana. That'll be the person that says 91 is equal to 1.75.
Or you could put it on Microsoft Word on a chart. You can make yourself a chart.
You could do that too. That'd be perfect. Yes, I encourage that. So there it is. Remember, the confidence level will be given in a percent. You change that to a decimal. So I'm going to go over here and I'm going to write a couple down that you may not see, that you'll see in the homework, but not in the real world, because nobody is going to walk up to you and ask you for 70% confidence level. So let's do a couple, just in case for homework.
I thought
So
it
I'm
was
going to go over
5.
here and I'm going to say 70% confidence level. 70% confidence level would be alpha 0.70. Therefore, alpha would be what? 0.30. Alpha over 2 would be, what's half of 30 cents?
15.
1500. And I write that in 4 digits, so you will know that's an area. So I need to do second, vars, inverse norm, left, 0.1500. And somebody give me that z-score. No negative. Just give me the z-score, 2 digits or 2 decimal points. Inverse norm, 0.1500.
Okay. 1.04.
So this is an example of a homework question that may ask for 70% confidence level, which nobody would ask you for that. That might as well just say, just give me a half-assed guess.
The homework is asking me for an 85% level.
Okay, so 85. I'll do 85 in this column. Example, 85% confidence level. So that would be 0.85. Therefore, alpha is equal to 0.15. What's half of 15 cents?
7.5.
0.750. 7.5, you're right. And somebody do a second vars inverse norm of 0.0750. Give me 2 decimal points.
1.45.
And there are 2 examples that the homework may ask you about.
I'm sending you some homework questions that aren't quite like that. They're more complicated.
I'm sorry, what?
I'm sending you some homework questions that aren't like that. They're complicated.
Okay, well, when we get there, I'll go over them, okay? We haven't even started yet.
Okay.
Okay, because this right here is so you can write you an index card or like you said, Miss Macagina, in a spreadsheet, and heck, you could do it up to 75% if you felt, if you wanted to do that. But I just pick 90 to 99 because those are the most asked questions. And these are two examples of what would happen if they gave you one less than 90. You take that number, change it into a decimal. You find the complement. You divide the complement by 2 and take it to 4 decimal points. 4 decimal points should say, oh, that's an area. So I got to use the inverse norm to find the z-score. And that's how you find the z-score for a confidence level. Okay, so this is for later, and I'm going to leave it on there just for a few seconds so that one or two people that watch the videos, you can pause it and write it down. Okay, now, in Chapter 9, we're going to be talking about what's called p-hat. P-hat. There it is. I want you to write it down. Slideshow, current slide. It is a point estimate. I'm going to write my definition out here.
You call it a p-hat?
P-hat. It's got a little hat on it. See it there? P with a little hat on it.
Oh.
Point estimate. The value of a statistic lowercase means that you're talking about the sample, okay? That estimates the value of a parameter. Usually a point estimate is a percent, a decimal, or a fraction. It's either a percent, a decimal, or a fraction. Sometimes it may be given to you as a decimal or a percent. Sometimes it may be given to you as 200 sick people out of 500 employees. And you have to find p-hat. P-hat is equal to x over n. What is always the biggest number?
The x?
I've been saying it since the first week of class. What is always the biggest number? I really don't think y'all listen to anything I say.
It's not x? The
No, it's not x. I've been saying it since the first week of class.
Are you referring to the denominator?
N. I have been saying N is the biggest number in every single chapter. So y'all want to write it down again? N is always your biggest number, so therefore it is the denominator. So I could say in a problem, I could say the proportion of sick employees, 211, to non-sick employees of 500. Therefore, you would say p-hat is equal to what?
500. Wait.
Would
What
that
is
be
my x?
211 over
Over
500?
500. and then you would calculate that to a decimal. Somebody give me a decimal, usually the 2 digits, but sometimes they ask for 3. Somebody give me a decimal of 211 over 500.
2 decimal places, it is 0.42.
Okay, so I just calculated p hat because they gave me a paragraph, and it basically said blah 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 sick 211, and the company employs 500 employees. So you can gather that p hat is 211 over 500, which is equal to 0.52. They may also, let me put given right here. That's one example. Another example could be a recent survey calculated that 42% of people drink. Okay? P hat is equal to what? 0.42. Y'all remember me saying in the last chapter that area, probability, and percentage is the same thing? That carries over into here. Do I have a percent here? Yes. I change it into a what? I change it into a decimal. Here I didn't have a percent, I have a fraction. I changed it into a decimal. Another experiment, another example. A recent poll says there is a 0.58 probability that you will get a speeding ticket. Okay. Again, I don't have a fraction. I don't have a percent, but I've got a what? A decimal. So p hat is equal to 0.58. Now, I just gave you 3 test questions that could be on the test. Now, I want you to look at those questions because that is not difficult work. I'm not going to make this test hard because I've only got a week and I'm only covering 2 sections out of 5. Notice on your outline, I could be going into chapter 10 Friday, but I'm not. All right, so there's one question. A recent poll says there is a 0.58 probability that you will get a speeding ticket. So we don't have a fraction, we don't have a percent. So the only number that's given is that 0.58. So p hat is equal to 0.58. Give y'all a second to write that one down, and I'll put the other page on there. I want to make sure you understand these 3 givens because I don't want you to mess that up on this test, which I know some of y'all can break an anvil with a banana.
Break a what?
Forget it.
Yeah, you keep on saying that. I don't know what that is.
You ever seen Coyote versus Roadrunner?
Yes. Yes.
Okay, what falls on the coyote's head all the time besides rocks? The steel anvil.
Oh, yeah, okay.
It's made out of iron. It's indestructible. But some of y'all, as students, could break one with an anvil. I mean, with a banana. All right? These two right here. A recent survey shows that it's calculated that 42% of people drink. 42 is a percent, so I changed that into a decimal. And that's p hat. Here, I'm given numbers and I make a fraction. Oh, let me go ahead and do that too, because somebody will. Okay, I forgot one. Here's another given. Three-quarters of people polled says that cars kill people. Okay? The cars just crank up and they just run in, run you down, and run you over. No people are involved. Just cars kill people. What is p hat?
0.75.
0.75. Good job.
Mr. McClure, the homework questions, I'm trying to do them. They're not quite like that, though. They're more complicated.
That's because I haven't gotten there yet.
Okay. Sorry.
Y'all pushing my buttons today. All right, so there are 4 questions right there that I will give you on the test. I will search them out and I will put those 4 questions on the test, and I will have one person in here miss all of them. Okay, there they are right there. You're given 2 numbers, you make a fraction. You're given a percent, you change it into a decimal. You're given a decimal, you rewrite it with p hat in front of it. You're given a fraction, you change it into a decimal. Those are the 4 examples that I could give you on a test. And that is what p hat is all about. And that's what I was showing you right here. So there's a question right there. Now put this one down. This will be another example. Now, are these going to be wordy questions? Yes, they're going to be very wordy. All you need to look at is the numbers. In a Quinnipiac poll, which is a very, very big poll organization, 1,783 registered voters nationwide, whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. So somebody tell me what p hat is.
$11.23.
It would be no.
1123 over what?
23 divided by 1783.
Good.
Which
and
is
that's equal to
0.62.
62.
Or actually, it would be 0.63. Sorry.
0.63. There you go. So that's another question I could give you on the test.
So you put the smaller one in the top.
Yes, because n is always your biggest what?
Number.
Yes.
Okay.
I think y'all are intentionally doing that to me today.
I'm sorry, I'm not.
I'm picking on you, Miss Macagina. All right. Let's move on. Find you another question. And there's their answer right there. There is your confidence interval. Let's write that down. There is a difference between a confidence interval and a confidence level. Confidence level is what you desire. Write that down. in a non-creepy way. Confidence level is what you desire. I want a 98% confidence level. Confidence level, which is CL, equals confidence level is the desired level. It's also what will be given.
Priority 1 message coming in on
Okay.
secured channel.
It's always going to be the desired level. The question will always ask you what if a 95% confidence level, all right, you want a 93% confidence level. The confidence level dictates the confidence what? The only other word that's written on the slide.
Would it be the confidence interval?
Yes, sir. You're on the ball, Mr. Michelle. The confidence level dictates the confidence interval. The confidence interval is what you calculate. So for those of you who want it in plain terms, the confidence level is the desired level, and it's usually given. The confidence interval is what you calculate, and it's usually written in form brackets, a number, comma, brackets. In other words, from this lower level to this upper level is the confidence interval. So I could have a 0.53 right here and a 0.58 right here, or 0.59, yeah, 0.59 right here. And I know that the middle, P hat, is equal to 0.56. And that's in the middle. And I'll get to that here in a few minutes. I'm not going to be able to get to it very fast, though. I'm running out of time. Now, here's where they get into alpha. You've already got it. It says, for example, a 95% confidence level, alpha equals 0.05. We've already covered that. Implies that 100 different confidence intervals are constructed, each based with a sample, same population. We'll expect 95% of the intervals to contain the parameter and 5 to not include the parameter. What they're telling you there is 0.05 is the complement of 0.95. That's what they're telling you. Okay, we've already covered that, so I'm not worried about that. Okay, so here is the confidence interval. Write that down. I've already wrote it down, but I'll write it down again. The confidence interval is going to have P in the middle, P hat in the middle, and then on the left side, it's going to be the margin of error minus, and on the right side, it's going to have the margin of error what? Plus. Do y'all remember us doing standard deviation?
Mm-hmm.
Okay, everybody in here, so nobody's going to say, what's the standard deviation? All right. Do y'all remember me drawing a number line
What
and
happened?
saying that 0 is in the middle and 1 standard deviation be +1, and then 1 over here be -1? Y'all remember me doing that? And mean is equal to 100, and the standard deviation is 5, so that'd be 105. And negative what? 95. Y'all remember me doing that? So if I carried it out to 2 or 3 standard deviations. Well, that's what this is. If I have a P hat that's equal to 0.55. And I have a margin of error of 0.05. Then my confidence level, my confidence interval is going to be 0.50 p hat 0.60. Now, before everybody starts going, what do you do on the right side of 0.55? What do? You add or subtract?
Add.
So what's 0.5? What's 55 cent plus 5 cent?
60 cents.
And what's 55 cent minus 5 cent?
50 cents.
And that's how you construct your confidence interval. So what are you going to be asked? Well, you're going to be asked to find p hat, which I've already showed you, and the margin of error. But I haven't shown you the margin of error, and I'm going to stop here in just a minute. I'd like to get to the margin of error formula, which will be probably on the next slide. Well, I'm going to try to get there. There it is. Z, well, I'm going to write it. Don't write that down. Z PQ over N. Z PQ over N. I'm going to write it down for you. Margin of error equals Z times the square root of PQ over N. It was the square root, wasn't it? I believe it was. Yeah. The square root of PQ over N. So that means that we have two formulas that we need to worry about. The first one is P hat equals X over N. And the second one is margin of error is equal to Z score times the square root of PQ over N. Now, I don't have time to do a problem, so we'll have to wait. I'm sorry, because if I go over, some people, well, I tell you what, I'm going to go over. Those of you that want to leave can leave. I'm going to do about 5 minutes, and I'm going to do a problem, so you can leave. I'm not taking the roll, so not the last week of class. So you can go ahead, and I'm going to do a problem right quick.
Can you do a homework question?
Say again?
Can you do a homework problem?
Yeah, hold on. I was just going to make up one. It'd be quicker. Hold on.
I emailed you some.
I kind of figured you did.
I tried those several different ways and I keep getting the wrong answer.
Well, I hadn't shown you how to do it till just now. Why'd you try it when you didn't know how to do it?
I still don't.
All right. Okay, here they're giving you the opposite. That's not the example I want. Okay, but I'll show you how to do this one. Okay, the lower bound, determine the point estimate of the population proportion, the margin of error for the confidence level, blah, 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 blah. Okay, the lower bound is 0.619. The upper bound is 0.911. So how do we find the middle? Somebody from algebra or from mid-range, tell me how we find the middle.
Would you add the lower and upper bound and divide it by 2?
That's mid-range. Mid-range is the same thing as the center. Lowest plus the highest divided by 2. And that's going to be 0.619. And somebody do it in your calculator, please. 0.911 divided by 2. What?
0.765.
765 should be your answer. And that is p hat. Now, of course, if they say, what is x? Well, you got your other formula. P hat is 0.765 is equal to x over, what's the n? 1,000. Multiply both sides by 1,000. And x is equal to 765. So that's how you do that problem. Now, that's not the problem I was wanting to do, but that is a test question. That's a good question, Miss Macagina. Here's one that I would give you, as far as, I want a 95% confidence level, find the 95% confidence interval, blah, 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 blah. So I'm going to do it right quick.
Then it asks what the margin of error is.
Plug it into the formula. Okay, hold on a second. That's what I'm fixing to do. All right, so 95% confidence level. I want a 95% confidence level with x is equal to 5, or not 5. X is equal to 275, and n is equal to 500. Now they're not going to give you that. They're going to write it in a paragraph, and you've got to find the bigger one and the small one. Okay, a 95% confidence level, and let's go ahead and do that first. So at p hat is equal to x over n. Somebody give me 2 digits, please, 2 decimal points. Point what? Okay, I couldn't hear you. Those background noise. Point
0.55, I believe she said.
0.55. Therefore, what is q hat?
Would that be 0.45?
Good job. The complement. Now we know the margin of error is a z-score. Well, wait a minute. We don't have a z-score, Hubert. Well, that's what the confidence level gives you. Somebody look on your index card. What is the confidence level? What is the z-score for 95%?
1.96.
There's your z-score. There's your p. There's your q. And your n is equal to 500. So plug and chug. Margin of error is equal to 1.96 times the square root of 0.55 times 0.45 divided by 500. And somebody crank that out, please. I just want 2 digits, please. It's probably going to be something like 0.03 or 0.07. I got 2 digits yet or 2 decimal points? Well, let me go ahead and type it in, and somebody will shout it out while I'm typing it in. 0.55 times 0.45 equals, divided by 500. Now it's about when somebody will shout it out. Raised to the 0.5 power times 1.96. And that's going to be 2, 0. So the margin of error, we have no margin of error because it comes out to be 0.004. So 0.004%. So what I'm going to do is show you how to use that. So what do you do with the mean and the standard deviation? What do you do on the right side? You add it. What do you do on the left side? You subtract it. So p hat is in the middle. So your confidence interval is 0.55 in the middle and 0.554 on the right, and what, 0.546? Somebody check my math. On the left. That's your confidence interval. Somebody add 0.55 plus 0.004. It should be 0.554. And somebody take 0.55 and minus 0.004. What do you get? Should be 0.546. And that's a confidence interval. That's a set at a 95% confidence level with X is equal to 275, N is equal to 500, and that's it. That's a 95% confidence level. This is a 95% confidence interval based on a 95% confidence level. And this is p hat in the middle. And then you add margin of error on the right, and you subtract margin of error on the left. That right there is a test question. I'll ask you 2 or 3 of these on the test. So make sure you hunker down on those in the homework that they're asking for confidence interval or margin of error or confidence interval, whichever. All right, we'll go over some more of those Wednesday. Y'all get out of here and have a good day. Miss McAgina, I'll go over your test question.
Have a good day. Thank you, Hubert.
All right, bye-bye. You have a good day too. All right, I'm going to shut off the recording. And